In this section, we will review the key multi-class classifier algorithms available in Azure Machine Learning Designer and the configurations or hyperparameters that are available to fine-tune these algorithms. The first kind is the multi-class logistic regression algorithm. Logistic regression is a well-known method in statistics that is used to predict the probability of an outcome and is popular for classification tasks. The two key parameters to configure this algorithm are, first, the optimization tolerance, which controls when to stop the iterations. If the improvement between iterations is less than the specified threshold, the algorithm stops and returns the current model. The second parameter is regularization weight. Regularization is a method for preventing overfitting by penalizing models with extreme coefficient values. The regularization weight controls how much to penalize the models at each iteration. The second algorithm is the multi-class neural network. A typical example of multi-class neural network used in multi-class classification include the input layer, one hidden layer, and the output layer. The relationship between input and output is learned from training the neural network on the input data. The three key parameters to configure the multi-class neural network include, first, the number of hidden nodes. This option lets you customize the number of hidden nodes and the neural network. The second parameter is the learning rate. This controls the size of the step taken at each iteration before correction. The last parameter is the number of learning iterations. That is the maximum number of times the algorithm should process the training cases. The third algorithm is the multi-class decision forest, which is an ensemble of decision trees. The algorithm works by building multiple decision trees and then voting on the most popular output class. The 5 key parameters to configure the multi-class decision forest algorithm include the resampling method. This controls the method used to create the individual trees. The next option is the number of decision trees. This specifies the maximum number of decision trees that can be created in the ensemble. Next is the maximum depth of the decision trees. This is a number to limit the maximum depth of any decision tree. The next parameter is the number of random splits per node. That is, the number of splits to use when building each node of the tree. Finally, we have the minimum number of samples per leaf node. This controls the minimum number of cases that are required to create any terminal node in a tree.